Here we find ourselves in section 3.3, and 3.3 is going to add to our experience by going over something that's actually very, very common, and that is these conditional statements. So they call it the conditional. And the conditional statements are if-then type of statements. They aren't always expressed directly like this with an if and then. Sometimes they use the word implies, and other times it's just implied through the wording that they use that it's a conditional argument. And we'll rewrite them always in these if-then statements. But our goal right now is to become comfortable with them and familiar with them. What we're going to do is establish the truth table for them, and then use that truth table to answer questions in the homework. There's also a second part of 3.3 called circuits, and I'll address circuits in a different video, and most likely just through homework examples, and we'll just talk along the way about them. So what I typed out here is a conditional statement, and it says, if I study long enough, then I will pass the exam. And so this is a traditional conditional statement, and it implies that if I study long enough, then I'm going to pass the exam. Okay, and so we want to establish the truth table and find out, well, when is this thing true? And so let me come in here and get a pen. Looks like I still have my eraser. So our big question is, when is this statement true? And we'll establish that through truth tables. So in order to do that, we're going to have to establish some notation as well as some language. And so I'm going to let P be, I study long enough. And Q be, I pass the exam. Okay. And so the notation that we use for the conditional looks like this. P and an arrow, Q. So P, often this is said, P implies Q. Or if P, then Q, right? All of those are the same. Now, P, the if part of the statement, the thing that has to be true first, P is called the antecedent, and they'll refer to it, and I will too later in this video. The antecedent is the condition that needs to be met first. It's the if part. And the Q has a familiar name, the consequent, right? So it's the consequence of the action, but they say consequent, right, in there. So P is the antecedent, Q is the consequence. And so let's just start establishing the truth table. So P and Q are going to be here. And so again, this is, if I study long enough, I will pass the exam. So if P is true, Q could be true, P could be true and Q could be false, P could be false and Q could be true, and P could be false and Q could be false. So let's talk about the truth table for P implies Q. Well, if P's true and Q's true, that means if I study long enough and then consequently I pass the exam, well, that's a true statement. That's what I was trying to make a claim about, right? This is the straight out statement. If I study long enough, I pass the exam. P being true here is I studied long enough. Q is false, so I did not pass the exam. And so therefore, my implication statement is false because the antecedent was true. I did study long enough, but I didn't end up passing the class. That's a false statement now. Okay. And then what about here? I didn't study long enough, but I did pass the exam. Well, that's still a true statement because we're making no suggestions about what happens if I don't study long enough. If I don't study long enough, who knows what's going to happen? And so that's still a true statement. And we've made no statement about that. And if I don't study long enough and I fail the exam or don't pass the exam, that's also a true statement. So the only time that we're false is if the antecedent is true and the consequence doesn't happen. So most of the time we're true in this regard, right? Very much like an or statement. right? Or is true almost always. So there's going to be a relation to that a little bit later on. So there's some things we want to notice out of this. One thing that we can notice, and I'll highlight that first, is that the only time it's false is P implies Q is false only if the antecedent is true, right? It's been met, but the consequence is false. Consequent. Okay, so P implies Q is false only if that first thing is true, but we fail to reach the conclusion. Every other time it's true. And so these observations will help us in establishing some truth to, let me get an object eraser here, some truth to some other arguments that are going to come later on as we evaluate arguments that are here. So that's the first thing to note. The second thing to note is, and I'm going to stop calling it the antecedent in terms of writing it out, but the second thing to notice is if P is false, right? If the antecedent is false, then P implies Q is automatically true. You are only making a statement if that first thing is held, then the second thing has to happen. But if the first thing is not held, then you're making no statement, so it's automatically true. So where is that? That's these conditions right down here, these last two. Let me back that up and just see if I can just get the last two. That's these guys right here. If P is false, right, if the antecedent is false, then it's automatically true. And there's one other situation that we can make note of, and that is, the third thing that we can make note of is if Q, the consequence, is true, then P implies Q is automatically true. Right? So anytime your Q is true, your consequent is true, you have a true statement overall because you've met that condition that's there, that's listed second. So pretty awesome, and we'll use those to evaluate things. And so as we do that, let's just go to an example. So what we're going to do in this video is I'm going to show you some examples that I make up, and then we're going to go look at some examples from the homework, right? I'll make a separate video there. So let's look at exercise 1. The first, or example 1. The first example that I want to do with you is something I see in the book and in the homework, and that is to construct, well, actually, let's not do that one first. We'll do that one second. Apologize for that difference of thought. So this one is going to say this: given P, Q, and R are all false, find the truth value for P implies not Q, implies not R, implies Q, right? So if P, then not Q implies not R. If not R, then Q. Okay. And so all we need to do is find the truth value to that. And so we'll start replacing these things. So as you do problems, I'd really recommend having truth tables with you. Have that or truth table with you, the and truth table, and now this if-then truth table, or the conditional truth table. And so we're working all in conditional right here. So let's go figure this out. So remember, P, Q, and R are all false. So what I would recommend is put in the truth values of each one of these. So I'm just going to come in here and in black, put some things in that we're going to need in the process. But in red, I'm going to come in and put the truth values. So we know that P is false and Q is false, so not Q is going to be true. We know R is false, so not R is going to be true, and we know Q is false, and so we'll put a false in there. So now we have false implies true implies false. Let's handle them one at a time. What do we know about false implies true? Well, we can look at our truth table, and that would be this one right here, false implies true. But we also know that anytime that antecedent is false, then we automatically have a true statement. So this is a true statement right here. Now, true implies false. Where is that? Let me come up here and erase this because it's not there. True implies false. If we had our truth tables with us, true implies false is right here. Sorry, make that look a little bit better. Well, that's overall false. This is the only time it's false, is when you've met the if condition, but the then condition is, or the then consequence is false. So true implies false. Well, we just saw that that's overall false. And so we finished that question. This is a false overall statement. Okay. The other thing that they'll have us do, and come back to black here, is your second example would be what I was originally going to write first. Construct the truth table for, and here's the statement, not P implies not Q implies not P and Q. Okay, and so we're going to have our truth tables on our side potentially as we go through, but we needed to construct the whole truth table. And so we know how that's done. We have the P and the Q needed there. And so we know to let P be true, true, and then false, false. Q go true, false, right? That way we get every combination. So that's our basis. And then we're going to have to find some aspects of this. So let me actually make this a little bit bigger. I apologize for not making those letters a little bit bigger. I know I'm going to have to write a lot in here, but I want you to still be able to see it. So let me make this a lot bigger. True, true, false. Get this up to the top, false. And then have these lines a little bit longer. And true, false, true, false. So let's work on that first one. So as I go to work on the first one, I'm going to need to know the values of not P and not Q. Okay, and so as I do that, let me just go get that. Let me go get my not P and not Q. So we know what we're going to do. We're just going to reverse these. So now not P is false, false, true, true. And not Q is false, true, coming through. And so we have this guy now established. Now what are we going to do? Let me come in here and circle this implication in red. Maybe I'll underline it too. We're going to figure out that first piece. So we're going to do not P implies not Q. And we're going to get the truth values of that red statement. Okay, so we know it. So I'm just looking at these two rows that are right to my left, and they're in the right order. So false implies false. Anytime your antecedent is false, your overall value is true. Okay, so these first two are true without thinking about it. True implies false. That's the only time it's false, and true implies true is a true statement. So now I have these red values in there. And, thinking about that, maybe I should have put them in that red color instead of in black. So I'm going to go do that really quick. So this was true, true, false, true. Okay, so there's the red. Now we have not P and Q. So we have those guys. So let me go and extend this guy a little bit so we can get that in there. And then I'm going to go to a different color. Hopefully green works okay. we're going to do green as this or, not P. I said or, but it's an and Q. Apologize for saying that. So that's actually these two columns right here. And so you have to be really focused. I've done problems where my eyes shift to different columns, so we got to be really careful. So remember with an and, it's most often false. The only time it's true is if they're both true. So the only time this and statement's going to be true is in this last column right here. Or I'm sorry, second to the last row right here. All the other ones are going to be false because because the first one is false because not P is false. This one's false because they're both false. And the last one's false because Q's false. And tracking that okay? So this one's false because of that guy. This one's true because they're both true. This one's false because they're both false. And this top one here is false because not P is false. Right? And so let me go through and erase some things so we can see here. So that's what we have so far. Now what we need to do is I'll come back to my pen, make one more column because we need one more column. And that column, let me go in blue, needs to be this blue statement. Now we're doing the whole thing. And we're doing this big blue arrow in the middle. This is the end of our truth table right here to get the implication. So what we know is, well, let's go term by term. I'll keep it in blue. So these last two here. So true implies false, that's false. True implies false, that's false. False is always true. True implies false is false. And so we get a truth table here that has 3 falses and a true in that regard. And so we're just building that truth table in there. So that's what we're dealing with as you go through some of the homework. You'll deal with some of the beginning stuff is taking statements and putting them in this if-then form. Then you're going to use this truth table to evaluate things like we did in example 1 and example 2. And then they make some statements here that I think are important for later on. The first one, this is the first of the equivalency statements made in this section. And the first one is that P implies Q is 100% equivalent. Remember that's what that 3 equal sign thing is? To not P or Q. So they're saying that these guys are totally equivalent, that we can take this conditional statement and write it as a disjunction, right? An or statement. So if I've said it out loud, but this is equivalent to. And so maybe it'll be helpful to evaluate an if-then statement in terms of an or statement. But let's make sure you see them as true. So if we had P and Q, let's go over this truth table again. Remember, it could be true, true, false, false, true, false, true, false. And remember our implication statement. So what do you remember about that? Do you remember that most of the time it was true? It was true every time our antecedent was false, and it was true when true implied true, and it's false here. So 3 trues and a false. That's very similar to an or statement. So now let's look at the same not P mixed with the Q, and then let's look at the not P or Q consequence. What they're saying is that it's going to be the same for each level. So picture this level coming straight across here. Not P would be false. Q would still be true. False or true is true. Because with the or statement, just one of them needs to be true. Not P would be false. Q would be false still. And so false or false is the only time it's false. Not P would be true. Q would still be true. And anytime there's at least one true statement, it's true. Not P would be true. Q would still be false. But we have a true statement, so we have a true. And so they're saying they're equivalent because the results of the truth table are exactly the same. So we have some equivalency right there. Okay, and so that's why they're saying it's equivalent. Now they're going to make a second statement so that I don't get far away from the first statement. I'm going to erase this justification knowing that you could back up the video. And I don't know if you needed to see that or just be told that they're the same, but I think it's good for you to see it because it helps us see how we're using truth tables even more. And so you want to think of this whole chapter as just a thinking exercise. Try not to get frustrated and just work through our truth tables. The second consequence is the negation of P P implies Q. Now, remember what that is. We're going to negate something. It's going to look like this symbol-wise. But the negation of P or Q, or P implies Q, is equivalent to, and then this shouldn't surprise you, P and not Q. And the reason why that shouldn't surprise you, this second statement, is this is just an application of De Morgan's law that you did in a different section, an earlier section. That you would distribute, right? So if number one, if P implies Q is equivalent to not P or Q, then you're taking the negation of not P or Q, which you know by De Morgan's law would be to distribute this negation. So we'd have P and Q, and then flip that thing. And so it changes from an or to an and. And so it's just an application of De Morgan's law. And so this could help us to really word statements the right way. So for example, they might say, determine the negation of if I'm hungry. So here's the statement. If I'm hungry, I will eat. And if they want us to do the negation of that, the negation of that statement right there is P and not Q. So it would have to be you're hungry and I am not eating. That would be the negation of that. I'm hungry and I shouldn't say am not, and will not eat may be a better statement. So you can negate statements. So it's the only way, if I'm hungry, I will not eat. I'm sorry, if I'm hungry, I will eat will be false if I take the negation of it. So this is the negation down here. The negation of that would be I'm hungry and I'm not going to eat, right? And so it can help us really get our language right, right? The opposite of that is not I'm not hungry and so I'm eating. No, it's if I'm hungry and I'm not going to eat. So I'm hungry and I'm not going to eat. And so we have that type of ways that can help us out. So there'll be homework along that line and so see if it all makes sense. I'll stop this video. We'll look at some homework together and then I'll create other videos for circuits for this section.